Hi, Bruce.
Hey, Mark.
Let's have a conversation about Postgres' place in history today. And I want to start at the beginning. When and where did Postgres start, and why that name?
Yeah, I've been involved with Postgres now for 28 years, and uh, something that impactful for my life, you'd think it was a big deal when I started, but just some software I downloaded that looked interesting and started poking around in it, and eventually realized it had potential. But what I didn't realize when I started is that Postgres had been around 10 years before I even started. I knew it came out of Berkeley, but as I got involved with the project, I started to learn that it had begun in 1986, which was way, way back in time for most people, including me. And it was done by Michael Stonebreaker, who had already written Ingress, which was one of the popular relational systems. But when he developed it in '86, he had a vision for where relational systems were going, and that's why it became called Postgres, because it's really post Ingress or after Ingress. It's kind of a funny play on words, and that's how it got the name Postgres. When I got involved in '96, it had just been converted from a language called Quell to SQL. And in fact, that's how the PostgreSQL got added to the end, to sort of highlight that it was an SQL engine. But it sort of started off obviously very minimal and very unassuming. And I don't think anybody really who worked on it in the first 20 years, either 10 Berkeley years or the first 10 years I was involved, really had any inkling that it would be what it is today.
So when did it become open source?
I believe it was open source even in the Berkeley days. You're talking the late '80s. Most software at that point was distributed on floppy disks or in magnetic tape. So I know that a bunch of people got magnetic tape of the Postgres source code in the late '80s and worked with it. And then the early '90s, as the internet started to get going, they had an FTP site that you could download it and use it that way. So it was originally funded by ARPA, the Advanced Research and Development Agency of the U.S. military. So the same people who funded the internet and BSD Unix funded Postgres. And that's one of the reasons that it was the first 10 years, it was only in the university and it had always been developed as an open source project.
So are any of these original creators of Postgres still involved?
No. And it was kind of odd. Like usually you want to have some kind of continuity, like leadership continuity, where sort of the institutional knowledge or software architecture knowledge kind of carries you through. And you've got a couple people who sort of are the old timers who remember why it was done a certain way. At the time we got involved in '96, there was only one maintainer, Jolie Chen, who had worked on it the last 2 years with Andrew Yu, adding the SQL language. And Jolie had a full-time job and really was doing this in a very part-time manner. And he was not in a position to continue working on it. So it was just kind of given to us. He said, this is really complicated software. And he gave us a warning. He said, you're going to need a few people with a lot of time, not a lot of people with a little time. And that we did struggle for years with that requirement. We had a lot of people with a little time, and some of the large infrastructure projects we had really struggled to implement. We had some huge heroes at that point. Vadim Mekaev, who now works for EDB, Jan Vik also were huge. Tom Lane, of course, Thomas Lockhart, Marc Fournier, who also works for EDB. So we had some really incredibly capable people, but it was a struggle in the first couple of years because you had those just humongous needs that we really weren't able to take on.
So why did the Postgres project or the open source project after Berkeley, right, even start? I mean, at the time, we had Oracle. Yes, it was in the nascent early versions. Man, SQL Server was still at Sybase, but it was a database. DB2 was around. What was it, 94? So we got Microsoft Access. Why another database that, you had to spend your weekends on to just even make it work? Why was that? Why?
Yeah, I would say that our early attraction was the open source nature of the project. So people who were already running BSD Unix, people who were running Linux in the later part of the 90s, were sort of saying, well, I'm running an open source operating system. Why am I going to have to buy, commercial database? And in those early years, most of our user base didn't have huge demands for the database. They weren't running huge banks, huge credit card processing, right? The stuff we all do today, bread and butter. We didn't have that. We had small websites, very, very small businesses that were using it. And they didn't have big demands. And this fit their need. And we were open source. And to the extent that they wanted a feature, or the extent that they felt led to contribute to this project, that little kernel, that small percentage of people who from your user base who really who felt called to really get involved, those were your developers, right? And I would say up until, I don't know, 2008, 2010 maybe, uh, open source was probably our biggest calling card. Right now, you kind of look at it, yeah, open source is huge, but it's huge now because it doesn't have lock-in. It's very flexible. You can put it on the cloud. It's extendable. I haven't even talked about that major issue yet. But the in the early years, it was just the open source nature. We were not in a position to take on Oracle level workloads or commercial database workloads. We took on workloads, but even at the middle end, let alone the high end of what they would be capable of. But it was enough. It was enough. There was enough people who were really challenged by the type of problems that we're solving and the architecture that we had, that was enough to keep us moving forward.
So let me go back to what Jolie Chen said, that you needed a few people with a lot of time, not a lot of people with a little bit of time. How did you do that? Because at the time there were no Postgres companies like today, right? So how did you just kind of call in sick, or not have weekends, or not have a life? How did you do it?
I think it's two things. Some of our people were incredibly gifted. Jan Vik and particularly Vadim Mekayev was just superb in their ability to get stuff done. And I think the other aspect of it was that these people were at a stage in their life where they were looking for some challenge. I know that sounds kind of funny, but if you think back on your life, there's certain points where your career hasn't started yet, or you haven't started a family yet, or you're still single, or you're challenged in some areas, and this is an opportunity to really shine, or an opportunity to sort of get away from it and do something really interesting. And I think that gave us some real stellar people in the beginning who spent, incredible amounts of time doing this, and they did not have super challenging jobs. That was actually my case as well. I had a job, I was writing, financial reports for law firms. I'd been doing it at that point when I started. I've been doing it for 7 years. I did it for another couple of years. But yeah, I was looking for something more than what I was doing, a way to grow as an engineer, and a way of learning from really super intelligent people. And that clearly was an opportunity here.
How do you explain that over those years, Postgres turned out so well. Even though it doesn't have the things that I know from my career in commercial software, right? It doesn't have managers. It doesn't have a QA team. It doesn't have sales engineers. But, how could that even work? That, a bunch of people downloaded something from the internet, and then, yeah, quite a few years later, but still, it turns out to turns out to beat the pants off the commercial competitors.
My initial reaction is, thanks goodness we didn't have those people. Because one of the things that was very clear early on was that, we were never going to have the assets of these other companies. We were, the assets of Oracle, the assets of IBM, the assets of Microsoft. We don't have any assets almost, right? So trying to do things the way they did them was never going to be possible, because we were never going to achieve anything significant if we had to develop software the way they did it. Fortunately for us, and history is, when we started in '96, it wasn't very clear, but it became clearer as the years went on. The open source is such a superior way of doing development that you now have Microsoft supporting us, and IBM supporting us, and Oracle producing a version of Postgres, and Amazon, and everybody else who's really kind of on that bandwagon. So we were very fortunate that the development model that we used, although it appears to be something that would not work because it's so non-traditional, has really taken over the software infrastructure industry, to the extent that most of the commercial relational databases, the proprietary ones, are in legacy status, I would almost say. All of the commercial operating systems are in legacy status. All the commercial compilers are in almost legacy status. Commercial text editors, middleware, virtualization, right? They're all that proprietary enterprise software that you and I really thrived on in the 80s and 90s is, I don't want to say on life support, but certainly in a legacy mode where new people are not choosing them at all. And they're choosing open source. Sometimes they're choosing open source because open source, but they're really probably choosing open source because the output of open source is so superior to the options that proprietary software gives you.
Yeah. But now, Postgres is not the only open source database, right? There were others, there's MySQL, there were some more like pseudo open source like Mongo, etc. But I suspect that maybe there were early design decisions that were taken in Postgres that kind of made it so innovative, right? Maybe talk a little bit about that.
Yeah, I think there's probably three aspects here. First, as I said before, the open source model is so superior, but some of the other ones had that capability. The second one was something that originally was part of the design in 1986, was that Postgres was post ingress because it was going to be an extendable ingress. It was going to be an ingress that could have pluggable data types, pluggable indexing methods, pluggable functions, pluggable stored procedure languages, pluggable operators, pluggable casts, there was a whole pluggable infrastructure that went around it. And I would say for the first 30, 25 years, that was almost inconsequential. It was there, but it wasn't utilized in any way. But what we've seen the past 12 years is such a shift in the demands for relational systems. So that now you have JSON as a requirement, you have full text as a requirement, you have GIS as a requirement, you have data warehousing as a requirement, you have AI now as a requirement, right? And a lot of these, not only the traditional relational databases, but the open source relational databases didn't have that extendability. So they were stuck with the workloads from the 90s or the 80s. And they tried to, they try and add it. I know even proprietary databases try and add data types and features for new workloads, but it never kind of works right. It's always it's always kind of slapped on the side, and it doesn't work the same, and doesn't back up the same, and it doesn't have the same transaction heuristics and so forth. And so even though they try, Postgres was always a very natural uh, at addressing today's workloads and into the future in a way that really no other system was. And in terms of design decisions, I think the big one was it because we didn't have sales, because we didn't have marketing, we didn't have anybody kind of forcing us. We were able to play the long game. So we were in MySQL's shadow for a decade, I would say. But unfortunately for them, they took shortcuts. The business side drove a lot of what happened. Uh, Once it was sold to Sun and then Oracle, even more business negativity kind of walked in there, and you had negativity from the business side, but you also had architectural shortcuts that were made. And over time, as we know with proprietary databases, those architectural shortcuts eventually sink the project. They become so overwhelming that you almost can't get out of where you're in. You're in a box. You put yourself in a box, and you can't deploy easily. You can't administer easily. Every bug is an incredibly complicated thing to fix, and your development just gets slower. It doesn't happen all at once, but it just gets it's just a little bit every year, and you see that happening. And fortunately, projects that have a vision, you basically talked about when I started. We started with 10-year-old software, and we didn't have any. We were all new. We all inherited that software. So our vision is 10, 20 years in the future. It's not this release. It's not this quarter. And I know that's frustrated you and EDB at times, but I think when we look back on it, it actually was the right decision, because now when we sit here, we are sitting on a very clean, highly polished, reliable piece of software that is ready for the next 10 or 20 years.
Good. Yeah, yeah. And let me just interject here for the audience a little anecdote about JSON, the JSON-B release, especially in Postgres. That was, what is 9.3, 9.4, something along those lines. And I was very, very excited about it. We did a lot of tests, and we knew it was faster than other JSON-B only databases, and really the way to go. And I was really looking forward to it being released on the usual schedule, I think in October or September, October. But October rolled around, and there was a beta 3. And I was pushing Bruce. And at the time, I was on the commercial side, right? And Bruce was more on the open source side. And I was pushing Bruce to, get the software out, get the software out. Come on, it's better than other databases. And Bruce said, nope, nope. The compression is not optimal. And if we release it now, we will regret it, and you will regret it for the next 10 years. I had to swallow that. In my whole career in commercial software, that would never have happened. But today, I am really glad that that was done, because now we have an optimal compression and an on-disk format that doesn't have to be changed. That makes upgrades so much easier. So that little decision that would have been an example of a commercially driven shortcut decision didn't happen because of the way the Postgres community managed its software process. And yes, painful at the time, but really good, even in a 4 or 5 year perspective. So it was very good.
Yeah, that's the example I was thinking of. Usually we catch the bugs real early, and that was one we didn't catch till August, and it was very painful.
Well, it wasn't even a bug. It was just
It was an
improvement opportunity.
something we weren't happy with, and we knew we would pay for it down the road. Yeah.
Yeah. So tell me, I mean, this is all good tech geek and DBA stuff, but why do developers love Postgres so much? I mean, that's really what's happening today. Developers love Postgres. They want Postgres. They love it. They use it more than any other database, commercial or open source. Why?
Yeah, I think actually the big turning point was that JSON-B. At the time I didn't really understand the importance of it, but we had other, as I said before, data needs have changed over the past 10, 12 years in ways that we couldn't really anticipate. But when JSON became a requirement, we put out JSON as a type, and then finally compressed JSON type, JSON-B. And people really sat up and said, wow, this is not your grandfather's database. This is a database that can do workloads that make our job easier. I think that's probably the key thing, that historically when people worked with, and that's actually one of the big, I think, attractions of NoSQL databases, where they create specialized databases to handle specific data needs, whether it's key value or document or columnar or graph, for example. And the assumption is that you have to have, that relational is relational, right? Workload of the 80s and 90s. But if you need something different, you got to go to a different database. That was, I think, carried into the 2000s. But I think the big aha for developers was that Postgres could do today's workloads, particularly JSON, and they started to look at other things like full text search and GIS and now AI. And they're realizing that I don't have to have separate data stores. I don't have to synchronize them anymore. I don't have to have what we call data silos, which is what happens when you put one data in one database and use a different product for a different piece of data, and you got to integrate them all together. And people don't like that. They'll do it as technology is evolving, as GIS is evolving, as AI is evolving, as full text search is evolving, as JSON is evolving. They'll tolerate that specialized database, and they'll tolerate the need to integrate that with their relational systems, where probably most of their most valuable data is probably in the relational system. But as that technology matures, and you see this over and over, relational systems back for decades, frankly, XML being a good example, where you have special databases, but as that data matures, you want to move it back into the relational system where you can do flexible analysis and flexible access to the data instead of a very rigid model, which is typically what you get from a NoSQL store. And I think that was a big aha. I remember, I think we made a great EDB, and you made a great contribution when we benchmarked Mongo against Postgres, and had really tremendous numbers that we did better than Mongo, which kind of weird because we do so much more than JSON B. But again, because of that compression, Mark, we really pulled it out, and that got a lot of people's attention. And I think they had written off relational, and were up until that point had accepted that they were going to need specialized data stores, and that was a wake up call for those developers.
Okay, so let me just go back a little bit to the community processes. Like, Postgres has no headquarters. There is no home country. Postgres is nowhere and everywhere. How does that global process work? I mean, every company, every organization needs to get together, has a building somewhere, but how could Postgres beat all those other companies without having that, not having that, and not having product management, etc., but especially this global aspect? Talk about that a little bit.
We were talking earlier today about the fact I've been working from home since the 90s, just out of requirement, out of necessity. I've always had an IT-related job, and back in the old days, I had 3 phone lines into my house. I think one of them was a modem, was always on. One of them was a fax machine, and the other one was a phone line, a voice line. And I got used to working virtually, and realized that some of the infrastructure that was in an office, or the requirement to meet in person was not as necessarily for my work, was as necessary as I thought it was. And I think what we found with COVID is that that's also kind of true for businesses, right? We're not, when you and I started, I was one of the few remote employees you probably had. And I remember being very conscious of that, because everyone was in the Massachusetts office, and I was down here in Philadelphia. But most of what I did was focused on the community, which kind of lives in that internet space. And what's happened, frankly, with a lot of businesses, and you and I are doing this all the time now, is our company is operating in that internet space now in a lot of ways, right? We see each other at conferences. We get together when we can, but we're actually quite capable of functioning effectively in virtual environments. And I think, again, that was possible in the 90s with modems, because that's the kind of work I did, where I would literally dial in and, be on a, I guess, 19K modem, 56K modem, whatever it was. But now with the internet, we're doing this virtually. I'm not physically with you, but we're working. So a lot of that workflow that companies really didn't understand was possible, even up to a couple of years ago, right? Now realize that, yeah, it is possible. So what we had done from 96 to today was to create a virtual infrastructure that exists using the internet, does not have any barriers, no buy-in, no logins effectively. It's a website, it's an email list, it's a wiki page, it's a file servers for downloads and so forth. And you just collect over time enough people who are dedicated to what you're doing, that they're willing to spend the time to keep that infrastructure running and to be involved in a virtual way and meet each other only occasionally at conferences where we actually, it's just I worked for probably 3 or 4 years till I met my first Postgres person. So it's amazing. It's amazing how much you can collaborate even if you've never met the person.
So talk about now. Let's look at the last or different aspect of collaboration. You started with individuals, yes, a few individuals with a lot of time. You added more individuals. But what's amazing today, the company is, supported and actively supported by software giants like Microsoft, VMware, Google, Amazon, NTT, Fujitsu, and I probably forgot a whole lot of them. Many of them compete in the marketplace, but they collaborate on the software. How does that work?
That's really sort of a secret sauce to who we are. Almost everybody who's in leadership now has gotten involved with the software first, has almost in every case volunteered to be involved with software first, and then has been employed by companies. And because there's that ethos of volunteering first, when they're employed by these companies, that company's not necessarily their first allegiance. Yes, they want the company to succeed. They want to do well with the company. They want to help promote the company. But at the same time, the only reason they're in the company is because they had volunteered, right? I mean, effectively, that's the process for the majority of leadership. And I think what happens is because you've done that, because your leadership has gone through that flow, even new people who come in, they kind of, and I think you've to some extent drunk the Kool-Aid as well, that you spend enough time with these people who are both dedicated to their companies and dedicated to the service that we're providing to the developer community and the world at large, and that's a very attractive thing to do. That's a very attractive purpose for spending your time. And I think that as people are employed, and again, in the early years, I think it was just myself was fully employed and Tom Lee was fully employed with Red Hat. So for the first couple of years, we had no full-time employees. I started in 2000 with SRA, and I think Tom Lane with Great Bridge, and then Tom Lane was employed by Great Bridge, and when Great Bridge closed, I went to SRA. Tom Lane went to Red Hat, and I believe until 2005 or 8, we were the only two full-time people. But what happened is that as EDB and other big companies started to get involved, and EDB was one of the big early ones for sure. And NTT probably was the other big one we had. They had full-time people, and we could start to take on some of these bigger projects because we had the long amount of time necessary to pull off a restructuring or a rewrite of a subsystem or whatever. And as it continued to snowball, we continued to get more companies, more people. The cloud vendors, which were originally very standoffish in terms of interacting with the community, contributing to the community, they're now seeing the value. Clearly, AWS, Microsoft are clearly in that camp. So it's kind of snowballing. It keeps getting bigger and bigger. And fortunately, that sort of unusual ethos of you're working for the company, but that community process and that community identity is very important to them. And it does help us as an organization run very smoothly and in a selfless manner that would not be possible if people more only identified with the company they worked for and not the project goals itself.
Yeah. Well, thank you, Bruce. That was a really interesting, not just place in history, but a journey through history. So thank you very much for this conversation.
Great, Marc.